Dear students, today we will see construction of LED, that is light emitting diode. Now before we go to see what is an LED, first we will see what does PN junction say to us. So if you see a PN junction, if you see a P-type structure and an N-type structure, you can see it like this. This is P-type structure, this is N-type structure, and in P-type material, holes are the majority charge carriers, and in N-type structure, electrons are the majority charge carriers. Okay, and when you join P and N junction, holes from P-type will travel to the N region, and electrons from the N-type, which are the majority carriers, will travel to the P region, and after some time the crossover stops, because once the hole leaves its place and go to the N side, or the electrons leaves its place and comes to the P side, that time the vacant places become ions. So these in P type, those becomes negative ions, and in N type those becomes positive ions. Now these are ions which are immobile. They will not move. They are not your charge carriers. They are only ions which are immobile. So this develops a depletion area between P and N junction. Okay. Now if you want to forward bias this diode, if you want to make this diode conduct, that time what we have to do is we have to connect a positive terminal of the battery to the P side, positive, and negative terminal of the battery to the N side, so that this positive will make the holes to move ahead, and this negative will make the electrons from here to move ahead. Now if the holes and electrons want to cross over, then they have to overcome this potential barrier whatever we are having. It is 0.3 volt for germanium and 0.7 volt for silicon. Okay. Now in that case, once we increase this voltage, the holes from P type will start traveling to N region, and electrons from N type will start traveling to the P region. Now here if you see the holes and electrons, the electrons are in the conduction band and the holes are in the valence band. But once an electron from here comes and meets this hole, it is coming from higher energy level to lower energy level. That means there is a recombination. There is a combination of hole and electron, and there the electron from higher level of energy is coming down to lower energy of level, and in that case it is radiating certain energy out. That radiation of energy which is coming out is heat in case of a normal PN junction diode. But in case of a LED, where it is highly doped and the materials are different, that energy which comes out because of recombination, that energy is in the form of light. Students, now we will see construction of LED. Now as I have shown in this figure and various layers I have shown here. The top layer here can be called as a cathode, and the down layer over here can be called as an anode, and these are the two terminals of your LED. One is cathode and one is anode. And the main thing over here is how we are going to form this junction. Whatever we have formed, this junction, how we are going to form. Now this junction is formed between P-type material here and N-type material here. So here N-type material is made up of aluminium gallium arsenide, and P-type material is made up of only gallium arsenide. So this junction is called as a heterojunction. So it is a dissimilar materials what we are having. In N-type we have aluminum, gallium arsenide, and in P-type we have gallium arsenide. So this will act as a P-type material and this will act as an N-type material, and the junction between them is the PN junction what we are having. Now these materials are such that what we saw in our basic study of a PN junction, whenever an electron from the N type crossovers and go to the P type region and recombines, Whenever an electron from N type crossovers and go to the P type in the hole section and recombines into the hole, whenever this recombination takes place, the energy which is released in LED is a light. Whenever one electron and one hole recombine, one photon is emitted. That is the element of light. So whenever this recombination takes place of electrons and holes, light is generated. Now that light depends on how you are forward biasing this structure, how much voltage you are applying, what is the current flowing. As much current flows, that much light will be emitted from this structure, from this junction, from this surface area. It is a structure in which the light is emitted from the surface area of the junction, and as we can see here, we have connected a fiber, and through that fiber light is coming out. The light will come out only when anode is made positive with respect to cathode, forward biased, and that current is increased. In that case, the light is emitted from this structure. So this is your structure and working of LED, that is light emitting diode.